Now we're going to look at examples of graphing quadratics using vertex form. So here in number 1 we have y equals x minus 3 squared. This is in vertex form, and we know that because we have something with x inside of some parentheses and it's to the power of 2. The first thing that I'm going to do is I'm going to find the vertex. Now if we remember our vertex form, that's y equals a x minus h squared plus k. Our vertex is the h and the k, but remember with h we need to switch the sign. So here if we look inside of our parentheses we have minus 3, so our vertex is going to have the h value of positive 3, and then we would essentially have a plus k on the outside, but if there's nothing there then we can assume that's a 0. So our vertex is at 3, 0. So let's go ahead and plot that. To the right 3, up 0, there's our vertex. Now I'm going to find the y-intercept. The y-intercept is where x is equal to 0. So if I substitute 0 in for x here, I have y equals 0 minus 3 squared. And then we're going to do PEMDAS. Inside the parentheses first we have 0 minus 3, which is negative 3 squared. And a negative times a negative is a positive, so now we have positive 9. So our y-intercept is at the point 0, 9, and we can go ahead and plot that. Now I can find my axis of symmetry. Remember, my axis of symmetry is at x equal to my h value. Again, we're switching the sign here, so our axis of symmetry is at x equals 3. And I'm just going to put a dashed line as that vertical axis of symmetry. And then I'm just going to use that y-intercept and my axis of symmetry to find some other point on my parabola. And to do that, I'm going to go for my axis of symmetry and see how many units away that y-intercept is. So from the axis of symmetry, I went to the left 1, 2, 3 units to get to the y-intercept. So now from that same starting point, instead of going to the left, I'm going to go to the right 1, 2, 3 units. So there's another point that's on my parabola. And now I can go ahead and draw that U shape. So here is what our parabola looks like. It's that U shape where now we have a minimum because this is the lowest point of our graph and then it bounces off and goes back up. So we have a minimum, I'm going to circle min, at, and our minimum is at our value of k. So the lowest that this graph gets is 0. So we have a minimum at 0. Our domain, we have arrows pointing to the left forever and to the right forever, so our domain is negative infinity to infinity, or all real numbers. I'm going to write all reals just because it's easier to write. The range, the lowest that this graph gets, is 0, and then we have arrows pointing upward, so it's going towards positive infinity. And then we need the number of roots. How many times does this graph touch the x-axis? In this situation, it only touches it once, so we have 1 root. Let's look at some more. Y equals negative x plus 3 squared plus 5. So for our vertex, it's hk. Switch the sign inside the parentheses. So we have negative 3, positive 5. Our axis of symmetry is at that h value, so we are at x equals negative 3. Our y-intercept is where x is equal to 0. So in my equation, I'm going to put 0 in for x, negative 0 plus 3 squared plus 5, and we got to follow our PEMDAS rules. Parentheses first, 0 plus 3 is 3. Then exponent, so we're going to square that 3. So we have negative 3 squared is 9 plus 5, and now we have negative 9 plus 5, which is negative 4. So our y-intercept is at the point 0, negative 4. So now I'm going to start plotting things so I know what this looks like. Negative 3, 5, 0, negative 4, axis of symmetry, count how many units away our y-intercept is. 1, 2, 3 to the right, so now we're going to go 1, 2, 3 to the left, and we can draw our parabola. Now this time, since our parabola is upside down, it's that U shape that's upside down, we have a maximum, and that maximum is at our k value, which is 5. The domain is still negative infinity to infinity, or all real numbers. The range, this time we have arrows pointing downward, so we're starting at negative infinity. And then the highest, the max, is at 5. And now we have to find our number of roots. So look at our x-axis. How many times is it touching that x-axis? There's a root, and there's a root. So here we have 2 roots because it's touching the x-axis 2 times. Let's look at one final one. If you're feeling okay with this, you can go ahead and pause the video. If not, we're going to do another one together anyway. Y equals 2 times x plus 1 squared minus 3. Our vertex, switch the sign for h, keep the sign for k, negative 1, negative 3. Axis of symmetry, x equals h, which is negative 1. Y-intercept, the x value is going to be 0. So when we substitute that in, we get 2 times 0 plus 1 squared minus 3. Parentheses first, 0 plus 1 is 1. Squared minus 3. 1 squared is 1. So we have 2 times 1 minus 3. So we have 2 minus 3, which is negative 1. So our y-intercept is at 0, negative 1. Vertex was at negative 1, negative 3. 0, negative 1. Axis of symmetry through that vertex. This time our y-intercept is only 1 unit to the right, so now we need to go 1 unit to the left to figure out the other point, and a rough sketch. In this case, our U shape is regular. It hasn't been flipped upside down, so we have a minimum at our value of k was negative 3. The domain, as usual, all real numbers or negative infinity to infinity. The range, the minimum is negative 3, and then it's going up forever. And once again, we have a graph with 2 roots because it's crossing the x-axis 2 times.